Number 32. Use the given representations for H2Z, Hz minus, and Z minus 2, as well as the space-filling structures for H2O, H3O plus, and OH minus that appear in Chapter 9 to depict each equation. Label the acid, base, conjugate acid, and conjugate base in each equation. So here we're given a couple of chemical equations that involve these formulas, these three formulas, and water, hydronium, and hydroxide. So let's see what's going on. The first one, well, I've copied them over on the right. So the first one is H2Z comes in contact with water to form Hz minus and then H3O plus. Now, first of all, I've put the space-filling structures for these up top. So there they are. And perhaps you can see that in this first one right here, the H2Z is going to be donating a proton over to water. Afterwards, water has 3 protons, or 3 hydrogens, and so it's H3O plus. This is hydronium. So in that sense, you can see that the H2Z is acting as an acid. It donates its proton, so water is acting as the base since it accepts the proton. Once H2Z loses the proton, it is left as Hz minus, so that's the conjugate base of the acid. And after water accepts the proton, it's H3O plus, the conjugate acid of that base. Part B is similar. This time you start with Hz minus right here, and hydroxide, and the products are Z minus 2 and water. So you can see that Hz minus is acting as an acid, and hydroxide is acting as the base. The proton right here goes over to the hydroxide. So this is the acid, and that's the base. After the Hz minus donates the proton, it forms the conjugate base Z minus 2. And hydroxide accepting the proton forms the conjugate acid water.